I knew that when I knew that Catherine was going to speak before me, I actually took all the slides that had to do with neuroimaging because I knew that she was going to explain it much better probably. So I did work with neuroimaging. Now we are doing work with neuroimaging as well, but this has something to do with other kind of analysis. I'm a physicist interested in consciousness, and this is going to be like a roller coaster through the way I try to enter the problem. If some slides get a little bit technical, there will appear like little blue boxes below with what you need to get from the slides. So these are some of the things I care most about these days mostly. So we do have the intuition that our consciousness can be in different states. When we go to sleep, when we have dream, and these are extended, we don't really know how to compare them. We don't know the distance that exists between, I don't know, dreaming and being in an LSD treat, for example. We don't know even how to start. We don't know how many of them there are. I mean, we suspect that there are, I don't know, it could be an infinite number, it could be 20, who knows. We don't know if the states that feel in similar ways, they are associated with similar substrates at the neurobiological level, and we don't even know how to define them very well. That's part of the problem. So what I want, basically, the kind of thing I want to do with psychedelics, or the kind I'm going to explain today, is that we have the point of view of like the stuff, the kind of thing that's got shown, like you know, the neural correlates, and this is suppose if you are committed to a view of the world in which whatever happens in the brain fixes the contents of your consciousness, this will essentially lead to, well, to the first person point of view. There are many ways in this which in this is proposed to happen. All have problems. You know, you can say that the blobs in fMRI are identical with the contents of consciousness, or basically you have different levels of representation or self-representation. There is an emergent phenomenon, and so on. And then you have the data that you can actually access, which is difficult to access. Does it work? Yeah, so of course, it's one of the big problems in consciousness research is how to access this level directly. We don't know. We need basically a process of generating data. The word, the phenomenology comes from Daniel Dennett, and what he said many times is that the idea that all the information that is generated by a person, for example, in a certain state of consciousness, exhausts what there is to know for science about consciousness. And this is involved with things such as, well, the process of consciousness being accessed by other processes in the brain, doing reportability of stuff that you tell, I'm conscious of this and that, narratives, yeah, tell the story, and behavior. And some people even go as far as to saying that this doesn't exist and you can go directly from here to here. Well, Daniel Dennett, I think he is or used to be one of those. But I don't really care much about these, but essentially what I want to do is I want to relate this level with this level, because accessing this level, I do know how to do it. So, why should we care about serotonergic psychedelics if you're interested in consciousness science? Well, the first thing we know is that they target, as Catherine explained, a particular receptor, which is a metabotropic receptor. I will explain later what it is, but what it does is that it binds to the receptor with different efficiencies, so with different affinity, different drugs, and then something happens. And then, of course, this receptor is not expressed homogeneously in the brain, but has higher density, for example, in parietal areas and frontal areas that we already know that they're involved in consciousness. This is another way of showing what Catherine showed with the gene expression data. So, and they are very well characterized at the molecular level. So we know more or less what they do at the molecular level. So we can introduce metrics to compare different drugs. And you see where we're going. At that level that is so low, we can compare them quite well. We can say, this is how different molecules are similar in terms of the structure, in their molecular structure, or this is how similar they are in terms of where they bind in different places of a membrane of a neuron. And then the effects are complex. They allow to go beyond the simple idea that consciousness, I mean, you need like three numbers to define the weather, right? Like temperature, pressure, and humidity, but we still believe that one number will be enough to, measure all the complexity of consciousness, which is a weird proposition. And this obviously leads to an idea in which consciousness is along a line, and you have below like anesthesia and so on, and then deep sleep, and maybe up in the ladder you have Could be, I don't know, meditation, enlightened states, or the psychedelic states. But there could be something like this. It could be like a partial order, for example. Even though you know that anesthesia is at the bottom and wakefulness is at the top, you don't really know if deep sleep is more or less conscious than a seizure or than a vegetative state patient, or you don't know if light sleep is more or less conscious than REM sleep, and so on and so forth. And it is even worse than that, because we know that actually, as Catherine explained, the effects elicited by psychedelics have different dimensions. So this is for psilocybin, 3 doses. Even though the area that in the radar plot is smaller for the smaller doses and so on, the profile is quite similar, and different drugs have different profiles and so on and so forth. So even one dimension might not do. And then we have access to a large number of narratives, because people love to write about the psychedelic trips. They're very I mean, unless you are Aldous Huxley, then you are probably going to, in that case, you're going to write a good trip report. But then most of them are not so fun to read, but people do that anyway, so we can basically introduce metrics to compare them. And of course, the question I want to ask is how these two metrics are related, because one is at the objective level and the other is subjective. So, I like to think on multiple levels. The lowest level is the level of molecules, where we have neurotransmitters and drugs. We compare them in terms of how similar the molecules are. Then we have more complicated stuff like proteins. These are, for example, the receptors where these things bind to. We can compare them as well using different methods, and we can relate these levels. Then these things are embedded in neurons, right? And these neurons are distributed differently in the brain, and we can map how they are distributed, and what happens in the neuron depends on stuff that I will explain, maybe the concept a little bit later. And then we have how these neurons are connected, making up the brain, but the brain also has like no emergent functional activity, and then on the top we have experience, we have heterophenomenology. I will propose that we can use tools from semantic analysis to basically compare things within that level. So I tend to get into different problems, because I like reading, and sometimes you read something that you cannot take out of your mind. This is a wonderful book. You all know Albert Hofmann, and this is for me one of the real heroes of psychedelic science, Richard Evans Schultes. If I were to tell you what he did, that would be like another 20 minutes, so I won't. But when I was reading the book, it struck me this phrase that the dreamlike state becomes reality under psilocybin. And this, then I kept reading, and this kept appearing, and people compare these two things. So they say, well, can we produce some evidence that these two things are similar in a certain way? Well, we tried to do this. Basically, we took lots of reports from Arrowhead. Arrowhead is a place where people upload drug experiences, dream reports, and we have these other websites in which people upload dream reports, and they rate them with the different level of lucidity. So in a dream you can be more or less lucid. You could know that you're in a dream or not, for example. So this is more technical. Basically, we took the reports. We did lots that we discarded combination of drugs. We discarded drugs with very few reports. We distinguished, for example, peyote from mescaline, but we lumped together species within the same genus. We ended up with this number of substances, and we did this is a standard analysis to process text. So this is a bit of a technical slide, but basically what you need to get from here is that words, single words, and documents can be represented as vectors, like an arrows, pointing into different directions of space. And the angle between them basically encodes how similar the semantic content is. So if you have cat, you have dog, close, and computer is in a very different direction, because semantic content is different. So we distinguish between different classes of drugs manually, basically. You know the drill, because we just talk about it a little bit. Those are perhaps the ones I need to distinguish, and I will. So this is basically the ranking of all the drugs, depending on how all the reports put together are similar to dream reports of high lucidity. And there's lots of information here, but this is basically the top 20 of drugs which are most similar to dreams, and the top 4 of them is LSD, peyote, datura, and mushrooms. These are all drugs that induce deep alterations in consciousness. If you go to the other side, the less similar are drugs which do not elicit these alterations in consciousness. Then you could go to dreams of low lucidity, and you suspect you can have a hypothesis of what will happen, and actually, it happens more or less what we expected, that these plants like the Daturas and Brumansias climbed up the ladder because these plants induce a very strong hallucinating state in which you can lose lucidity that you are in that state like it happens in the dreams that most of the people had so no wonder. And again, the low lucidity, low similarity where drugs do not affect consciousness. Okay, so this is where things get interesting for me because is this common also to compare the process of dying to the psychedelic trip? But this starts to become weird, right? Because nobody died and then came back and say, it's like taking LSD, so how come you can do that? Well, there is an experience, and quite a stereotypical experience, called the near-death experience. This guy is Bruce Grayson, who is a very kind, senior, but guy who spent most of his life studying these experiences, and he was kind to share with us lots of reports, narratives of these experiences, so we could do the same thing with near-death experiences. And what we found didn't surprise me. What we found is that the dissociative drugs, especially ketamine, is the closest to a near-death experience. If you want to know why, we can talk after the talk. We can map what are the people talking about in the reports, like what are the recurrent topics that appear. So they talk about, of course, things that have to do with consciousness, with visual consciousness, but then we have also like stimulating effects in the body. They talk about preparing stuff, like in the way you prepare, like you go to the kitchen and prepare some, the recipe, the same for, of course, drugs. And then you have components related to dependency, and one that is a mixture of terms related to disease and relation. This is very interesting. And we can put different drugs in this projection in these dimensions, and then we can put the projection of the near-death experiences, and of course, the highest overlap is with ketamine. A cocaine experience is not similar to a near-death experience, unless you overdose, but in that case, it could be a death experience, which is a different thing. So then I'm asking, how we can link, and going back to the question I started with, we want to link these different levels, and the idea is the following. And again, I like to read, and this is a very inspiring and insightful quote from Phenylethylamines I Have Known and Loved by Alexander Nan-Shulgin, in which he basically says that a drug has different components, and he compares that to to the note that you can produce with an instrument, which has different harmonics, and with an instrument you can actually put the sound in an oscilloscope and identify these components that distinguish, for example, the sound of a guitar from the sound of a trumpet. But there are no psychic oscilloscopes. That's the point he makes. So you cannot define the harmonics in principle of a drug, but any eventual definition of a drug will require such a dissection eventually. And he goes even further. He says that the mental process might someday be defined by a particular combination of some components. So he was already thinking not in levels of consciousness, but in something more complex. So we did this study in which basically it was covered already by Catherine, but I'm going to do it quickly again. Why the 2A receptor? Well, one thing is that there is cross-tolerance between drugs that act the same receptors. If you take psilocybin today, tomorrow LSD will have less impact, and vice versa. You can prevent the effects with ketanserin, which is an antagonist of the 2A receptor, as Catherine perfectly showed. And this supports the idea that at least partial for agonism basically is what the molecule binds to the receptor and does more or less what the endogenous molecule is expected to do, is a common mechanism of the action. But then, if this is the mechanism of action, and we all agree that this is basically what happens, could it be, and does it happen actually, and it seems it does happen, that different psychedelic drugs can have a variety of effects, and how can this happen with only a single mechanism? So basically, people have thought about in different ways about this. For example, they said, okay, it has to do with certain setting. It could be because, as Catherine showed, they bind to other subtypes of certain receptors. Okay, so here is, this is basically the concept of functional selectivity, that is not only a process of binding to the receptor, but the shape of the molecule that binds to the receptor determines a sequence of events that leads to a different response. So you have molecules that are very similar to LSD, and they bind to, to the same receptor, but they do not lead to psychedelic effects because of this process. And the dose, of course, is a factor. We propose a complementary, which is not really mutually exclusive, hypothesis that this variety of effects could be related to also other neurotransmitter receptors. I think you asked a little bit about that, what happens with the other receptors. So I have 5 minutes, so okay. So yeah, so basically what we did is we took the data at the level of consciousness, molecules, and pharmacology. In terms of molecular similarity, well, this is very technical, but basically you put in a list all the atoms in a molecule, and then the first and second neighbors, and so on. And basically then, if the fragment was there or not, you put a 0 and a 1, and you have this bit string, and then you can compare bit strings, and then you can compare how similar two molecules are. This is not very difficult to do. Affinity, well, there are ways to basically to bind, to see how easily or how strongly a molecule binds to a receptor. We did the analysis with 2 sets of data. These are phenylethylamines, these are tryptamines, even though LSD is not really tryptamine. 18 drugs at 42 sites. And we also use a different data set with different drugs at different sites. And basically the result is, maybe you need to look directly here. This is the semantic distance. So this is how different they are in terms of what people report, in terms of the trip reports. And this is how similar they are in terms of the affinity, how they bind to different receptors. So what happens is, of course, the ones that bind more similarly to a wide range of receptors, not only serotonin subtypes, they're also more similar. And we replicated this with this analysis. We know this has problems. We know that. I mean, because binding is not the same as activating. This could be antagonists. There could be, for example, that there was antagonism and sort of the receptors, but then we got really carried away and we started doing stuff like building simulations, like docking simulations to this. Okay, you simulate in a computer simulation how the molecule enters the receptor, and then you have different places in which the molecule interacts with the receptor, and these are different type of chemical unions. So we build a fingerprint of these, and then we try to predict based on in which subunits of the protein the thing was bound to, whether it's an agonist, antagonist. We had great success for some receptors, like the 3C receptor. We can really predict with like 90% accuracy whether it's going to be an agonist or antagonist. How do we predict? Well, we take huge databases, we use data mining techniques, things to extract the fingerprints, and then we do lots of machine learning and stuff, and query properties who do know the properties, molecules know the properties, and then we predict. So, for example, and as an example, we can have these different recurring topics in the trips, and these are expressed differently across different molecules. So you can take the molecular structure of these drugs, and you can put it in all this engine we built, and you can basically predict how strongly people are going to talk about that based on the molecular structure. And even more, you can actually find which are the fragments of the molecule responsible for that. So, for example, the component related to consciousness, to changes in vision patterns. Well, we can, this is the predicted values, and these are the active values, and using machine learning models, we can predict rather well. But even more than that, we can just get what are the most important features, assemble them, and find which are the molecules that are like in the top of the ranking. This is 25A, a very selective 2A agonist. So I'm going to almost finish. This is all based on the past, and when people remember they did in the past. But we can also study the acute effects of the drugs. People talking under the effects of LSD, for example. And this here also comes with the blue box, that basically if we have vectors that represent the semantic content, then a person who has a flow of speech that makes sense over time, the vector will go more or less smoothly. But in certain, for example, psychosis, psychiatric diseases, the vector is like this, is jumping all the way around because people have this tangential thought. This is one of the markers of schizophrenia, for example. So we applied this method to LSD, and basically we found that LSD has more of these jumps, has a reduced coherence over time. People make these looser associations in their free speech under LSD. This data was acquired before neuroimaging experiments, and we found, here is a trend, but here is a real effect of increased semantic variability. It's even more than that. We can actually forget about what the words mean, and we can say, only what matters is how you go through the sequence of words, like a graph, right? This is called a speech graph. And these speech graphs, One of them is LSD and the other is a placebo. I think you can guess which one is one, right? So this is LSD and this is placebo, right? There are many computational tools to extract information from these graphs. These are the easiest to understand, like repeating the word, going from one word to the other, or like 3 loops. But all these results are summarized in that there is a reduced semantic coherence, people speak more, but with a reduced lexicon, more recurrent speech, more disorganized speech. So when people tell you that these drugs are psychotomimetic, they're not telling you what kind of psychosis. You have manic psychosis, you have schizophrenic psychosis. For many years, people thought that it was schizophrenic psychosis because in schizophrenic psychosis, people have more disorganized speech, but also they speak less. They have this flattened emotion. And one of the reasons is that in the 60s, they were giving these drugs to people in prison, and of course, they were intimidated, and they were not really happy. So we're in the cell, but the volunteers of this experiment were really happy, and they were really dying to tell, to tell the experimenter. We actually was Robin Carter-Harris, the interviewer, how it was for them. So they were elated, right? And they spoke a lot, but disorganizedly. So just to finish, I want to tell you a bit about the project we are doing. We just came from Kim's talk when she said the importance of naturalistic experiments. Those are especially important if you cannot afford a real one. So what we do is that we have this way of doing in Buenos Aires. I want to show you something. What we do is basically we do all these screening visits, interview, and then before the experience, we have questionnaires, we record an interview of text, which we're going to analyze using this method, and what people expect from the experience, and then people smoke DMT. They smoke like around 40 milligrams of DMT, with an EEG cap and all how it works. And then afterwards, we have also questionnaires, and we record the interviews and experience, and then we take DMT samples for analysis, follow-up questionnaires, and we have like 20 subjects, but we expect to have 50, and this is one of the good things about naturalistic studies, that since you are not paying for the drug, they are paying for the drug, it's cheap. Yeah, and I want to show you something. This is me. This is Carla, she's one of my postdocs. The shadow here is the subject. His anonymity is preserved. This is a quite artistic photo. This is a Buddha here. This is the set and setting the person chose for the experiment. Set and setting is important. People choose their own set and settings. And I don't know if you probably read that psychedelics do stuff like decrease the alpha rhythm. You read that, but you never saw it happening. I will show you happening. I will show you what I was seeing here in the screen, the moment the subject with the EEG cap, basically. So also the people choose the music. This one made a very good choice. Music in 12 parts by Philip Glass. So I will show you. You will see the strong alpha waves, and you will see a noise that the person who is helping her smoke does around her the moment the drug hits. And I'm almost finishing here. It's like seconds. Well, it will be seconds because that's how long it lasts, right? So, no, not real. That wasn't the button. I tried to the audio. Well, it seems there's no audio, but you see, this girl had huge alpha waves. You can see them. It's a pity there's no audio, but you will see at some point, like there's something starts to happen, right? And then they basically this synchronization, loss of alpha rhythm, increased complexity. It's a pity you cannot see the moment, because it's instantaneous, right? And then if you wait long enough, which we are not doing here, you will see how the alpha waves go back to baseline. All in 10 minutes. It's like consciousness in a nutshell. So just to finish, the one that we will plan to do next is the same process, but with ayahuasca group retreats, and there will be like 2 branches. Either we record individual interviews, like we're doing now, take samples and follow-up questionnaires, or we put all the people together in the room and let them talk among themselves and record all the conversation, the social interaction, what they are saying, who is saying what to whom, and we basically do the same thing. And the idea is that all these measures of improved mood after the experience and so on will be enhanced by this process of group interaction. So these are my collaborators. These are people who helped me a lot with these things. The people from Imperial College London, especially Robin. The Arrowitz, these are nice people, a bit old-fashioned, but nice people. This is my group. This is the group of people I work with. I've never seen people so motivated working at something from so different backgrounds in my life. So this has to speak about the meaning and purpose of studying psychedelic drugs. And just to finish, this work was done in Argentina, in Buenos Aires. I wish I could have like some funders here, but we don't get any money. But in Argentina there was a huge catastrophe. Nobody's giving money for any kind of project, so it's not about psychedelics. So I don't take it personally. But I wanted to tell you that, and that also, once more time, that this is in Argentina, because we tend to believe that there was like a golden age of psychedelic research in the 60s and so on, and now we have this renaissance. But nobody in the 60s, nobody was doing anything in Argentina in the 60s in psychedelics. You know, it was something more located in a few countries. But now I'm coming here, I'm from South America to show you all this. So this, basically, in my opinion, is part of the evidence that if there is a golden age of psychedelic research, is today, is not in the 60s. Thank you very much.